In the previous lecture, we have been talking about the motivation behind blockchain technology, and in this lecture, we are going to talk about how to represent blockchains. Okay, so first of all, a blockchain is a continuously growing list of records. These are the so-called blocks that are linked and secured using cryptography. It was first proposed back in 1982, and it was first constructed in 1991. Blockchain is the underlying technology and the data structure of cryptocurrencies. When we are dealing with cryptocurrencies, we are storing the transactions in the underlying blocks of the blockchain. In the previous lecture, we have been talking about a very simple example when a given person wants to send money to another person. And this is what we have been talking about, that because there is no trust between the clients, this is why we need trusted third parties such as banks. And the bank is going to store the information for the clients in a centralized database table. So there is the first client with all the relevant information, and of course there is the second client as well with all the information needed. So there is a centralized database in a server that's going to store everything. When we are dealing with decentralized blockchain technology, of course there are no centralized databases. It is the network itself that guarantees trust. And of course you may guess that in these cases the blocks of the blockchain will contain every single transaction and every single relevant information for a given transaction. Of course we are going to talk about cryptocurrencies in the coming chapters, and it is going to be clear. So blockchains are very similar to linked lists, where the nodes are the blocks in the blockchain and the references are hashes of the previous block in the chain. So references are cryptographic hashes. So we have the first node of the blockchain, we have the given data, we have a given previous hash, and of course we have the actual hash. The first block of the blockchain is called the Genesis block. For example, in the Bitcoin ecosystem, the first block is created manually by the algorithm, and of course there are no transactions associated with that given block, which means that the first block doesn't contain any transactions, any data. The previous hash contains all zeros, and the actual hash is, let's assume that it is 056FH. We are going to talk about how to generate these hashes that's going to identify every single block uniquely. This is why we have to consider the so-called SHA-256 algorithm. We are going to talk about it in the coming lectures. In this lecture, let's assume that we can generate hashes that can identify every single block of the blockchain uniquely. And then we have several other blocks in the blockchain. This is the second block. We can store any data we want. If we are dealing with cryptocurrencies, then of course the data is the transactions the given block is storing. Of course we have the actual hash H, J, I, 6 and 6. This hash identifies the second block uniquely, and as you can see we store a reference to the previous block. So you may guess that the previous hash is equals to the actual hash value of the previous block. If we have another block in the blockchain, then of course we can store whatever data we want, for example other transactions. We have the hash of the actual block, and of course we have the previous hash that is pointing to the previous block in the blockchain. So this is why we have been talking about that a blockchain is a continuously growing list of records that are linked and secured using cryptography. So we are using cryptography related hash functions in order to identify every single block and in order to point to the previous block in the blockchain. If we have another block, of course we can store other data. Of course we have a hash identifying the actual block, and the previous hash is pointing to the previous block in the blockchain. So we can come to the conclusion that with the help of these hash values, we can create this linked list like data structure, which is the blockchain itself. So the blockchain itself is similar to a linked list with hash pointers. Every node in the blockchain has two hash values, the own hash value and the hash value of the previous block, and blocks form a linked list where the nodes are cryptographically linked together. Essentially, this is the fundamental structure of a blockchain. I know that it is way more complicated. We are going to talk about how to represent a single node. We are going to talk about tree-like data structures. These are the so-called Merkle trees. We are going to talk about it later. At the moment, we can come to the conclusion that we can represent the blockchain as a very simple linked list with hash pointers. And of course, you may pose the question that what are we going to store in a given block? If we are dealing with cryptocurrencies, and this is exactly what we are going to talk about in the coming lectures, we have to store several information in a single block, such as the ID of the given block, such as the transactions, such as the Merkle root. We are going to talk about it, don't worry. We have to store the actual hash value and of course the previous hash value. This is what we have been talking about, that we identify every single block in the blockchain with a 256-bit long hash value, and of course we have to store the hash value of the previous block. This is how we can create a linked list with hash pointers. Then we need to store an integer, the so-called nonce, number only used once. This is an extremely crucial variable of a given block. During the mining operation, the miners will change the value of this variable until they find a valid hash value for a given block. We are going to talk about it later, of course. And finally, we need a timestamp. So every time a block is created, then of course the time will be associated with that given block. Okay, so these are the features and these are the variables associated with every single block of the blockchain. And of course, there are multiple blocks that are cryptographically linked together. In the next lecture, we are going to talk about how to generate these SHA-256 hashes that will identify every single block in the blockchain uniquely. Thanks for watching.